All right, day 12, block 2. So we're going to look at how we describe a distribution. Distribution meaning a data set. So I don't have the calculator up for this lesson, but you will want yours for the end part. We'll do some practice, but you won't need to see my screen to do that. So I would just have it close by so you can grab it at the end of this lesson. Okay, so a lot of vocab today. It says if you are asked to describe a distribution, you must include these 4 pieces of information. So you must say something about the shape, center, spread, and outliers, whether you have them or not. The shape, we look at the graph, typically a histogram or a box plot. So let's add that histogram or a box plot. The center will be the mean or the median. We don't usually report both. We'll talk about how to decide. The spread would be the range or the IQR. Again, we don't usually report both. We'll talk about how to decide. And then outliers, you look at the modified box plot to decide if there's any outliers, okay? So let's look at different shapes our data set could have. So lots of different vocab words. These are all the descriptive words you use when you're talking about shapes. You can sometimes use like multiple for one distribution, and we'll talk about that as well. So we're going to draw little sketches of what these kind of look like. So symmetric is pretty much what you think. We'll see how good I can draw this. So it looks, that's not great, but it looks, about even on both sides, where you could kind of fold it in half and it would match up nicely. Uniform might look something like this, where all like the frequencies are the same, right? 5 people fell into each category, would look very uniform. There's not one most common answer. Multimodal. Multi means many. Modal is literally talking about the modes of the data set. So mode is most frequent or most common. So multimodal would basically look like a data set that has many peaks. So it might look something like this. Okay, it has lots of peaks where there's a lot of frequency in that range if it's a histogram. Skewed right. Now these are the skewed are the ones that people mix up all the time. The word skewed means the tail of the graph. So let me draw it. I'll change colors so you can see. If it's skewed right, that means the tail is on the right side, not the peak. So it would look like this. Really high point on the left and then big long tail going to the right. Okay, that's kind of exaggerated, but see how the tail is on the right side? We'd call this skewed right. A lot of people want to call this one skewed left because that's where the peak is. It's not about the peak, it's about the tail. So on the other hand, skewed left means the tail is on the left side and then it peaks on the right side. So again, really exaggerated to make it really clear. Outliers. Outliers are easier to see on a box plot, so it might look something like this. If it's a histogram, let me just draw. Here's a histogram, and then maybe you have like a couple bars over here. That's a really bad sketch of a histogram, but there's a histogram. These guys would be our outliers. Okay. Unimodal, that means uni means only one, so only one mode. So these skewed graphs could be considered unimodal. It could be symmetric and be unimodal. That just means there's one peak. Bimodal means there's 2 peaks. So none of the graphs we've drawn so far have had 2 peaks. So it could look something like this. That would be bimodal, 2 high points. Okay, they don't have to be the equal height, but there's 2 of them. So let's use that vocab and describe some of these. So there's a lot happening here. We're going to first describe each distribution. These are the histograms. Okay, so we're just looking at numbers 1 through 6. So don't worry about the bottom part right now. Let's just look at the 6 histograms and then we'll match them up. So when I look at this first one, I see that the frequencies are all the same. That tells me right away I'm going to call this guy uniform. Okay. There's no modes, there's no most common, they're all equal, so it's uniform. You could say symmetric if you want, like I wouldn't mark that wrong, but I'd really be looking for uniform. The next one, I'm looking at this. If you kind of sketch over it, it helps see the shape. Okay, see how the tail is on the left? So this one's definitely skewed left. And it has one peak here, so we can also call it unimodal. The next one, if you again kind of trace it, not very good tracing, but that definitely looks symmetric. And again, one peak, so we'd also call it unimodal. Here's this guy. Okay, so that one would be called skewed right, because our tail is on the right side. And again, one most common answer. This one, this graph's a little bit tricky. So it kind of has this part and then you have this extra spot at the end. So I would probably call this one just unimodal because of this high point right here. I don't think I'd call this symmetric because of these guys, but I might say that there's outliers for this one. And then last one, if I draw a vertical line here, see how it matches pretty nicely? I'm going to call that guy symmetric. We call it symmetric when I can split it in half in the middle and match up both sides. So it doesn't have to be like a bell curve to be symmetric. Okay. So now that we have our histograms kind of described by shape, let's match them up. So there's a few ways to do this. I mean, the colors kind of help here, but let's look at the first box plot. I see these outliers here, and the only one I had clear outliers was number 5, so I'm going to match that one there. And this part kind of looks even, which does sort of match that first chunk we had. The next one, this looks like perfectly even here. So I'm going to say that one matches our uniform graph, which was number 1. Do you see how such a big part of the graph of the next one is over on the right side? That matches our skewed right graph. Okay, all this empty space here would go with skewed right, meaning all this wide space here would go with our skewed left, which was number 2. This one, now I could see how you would mix up B and E. They're pretty close. I see how there's a little bit more space here that kind of matches with the bigger left side. So I'd call that one number 6. If you flip these, it wouldn't really be that big of a deal. The colors in this case help match them up. And that leaves us with number 3. And that also matches this nice symmetric graph we had. Right. So the next part is something that we're going to take with us for the rest of the unit. So big idea coming up here, determining which data representation is the most appropriate. So meaning, should I talk about mean or median? Should I talk about range or IQR? That's what we're looking at here. So for the center, it says, what do you know about the mean and median of a symmetric graph? So here's a symmetric graph. Here's our middle part. They would actually be exactly the same if it's perfectly symmetric. Now that doesn't happen a lot in like real life data, but if they're perfectly symmetric, they're the same. So we're just going to say they are almost the same. The arithmetic middle and the like sequenced middle would be about the same. So I would have the mean here and the median at this point. Okay, so that's when it's symmetric. If it's skewed, they are not the same. If it's skewed, they are not the same. So if it's skewed left, the mean is smaller than the median. Okay, so in this graph, the median usually would, if it's skewed, we're going to talk about this in a moment, it's a better representation. So our median might be about here. This is just, I'm just guessing, and your mean might be down here. If it's skewed right, whoa. sorry. Then the mean is greater than the median. Okay, so like, because these are our values, like this would be 0 to 10, 10 to 20, 30, 40, 50. I'm just making up numbers here. In this picture, the median would be closer to like the peak of the graph, and the mean is being pulled by the tail. Okay, so the mean is going to be bigger if it's skewed right. Okay, if it's skewed, you want to report the median. Big takeaway here. If it's skewed, you want to report the median. If it's symmetric, you're going to report the mean. Okay, now let's talk about spread. So spread, the usefulness is limited because it's affected by outliers and skewed data. That's the range, okay? So range is better to report if it's symmetric. IQR is better to report if it's skewed. We're going to put that in a box here in a minute. I just want to show on a box plot what that means. So let me just quickly sketch a box plot here. Let's say it looks like this. Okay. Your range is from the beginning all the way to the end. This is the range. Your IQR is only talking about this chunk of the data. So if it's really skewed, the IQR is going to be better, a more accurate representation of the spread than if it, versus a symmetric data set, the range is better. So let's put all of that in one spot so it's all clear. This chart here, super important, really helpful tool to go back to. If it's symmetric, for center, you're going to talk about the mean. For spread, you're going to talk about the range. If it's skewed or has outliers, for center, you're going to talk about the median. And for spread, you're going to talk about IQR. Okay, to decide if it's skewed or symmetric, you're going to compare the mean and median, and, you're going to look at the modified box plot. You're going to do both things to decide if it's symmetric or skewed. Okay, you want both pieces. You want the data and you want the graph to kind of give you the full picture. So let's take that into consideration and do an example here. So it says the salaries for 15 NFL players of the Seattle Seahawks are given in this table. All right, this is a really annoying table of data. So up here we have these guys making millions of dollars. And then all these guys are making less than $1 million. I want you to put this in your calculator, in your list, and find the mean and the median. Mean is X bar, and median, it'll say MED, M-E-D, on your calculator. But when you type this in, you can type in just 9.7. You don't need like the millions, so just type in those decimals. And then for these guys, you're going to type them in as decimals. So I'll write out what you should type in. We won't see ones like this a lot, so I'll just show you right here. 0.88, 0.681, 0.62. So these are the numbers you'll type in your list. Let's make this one 0.8. Okay, so type in these decimals and then these decimals as well into your list 1 and calculate the mean and median using the calculator steps we talked about in the last video. All right, so here's my mean and median straight from the calculator, the 1var stats feature. So when I look at these, I can compare them. The mean is greater than the median. So that tells me it's skewed right. If the mean is bigger, it's skewed right. Okay. So this is based on your answer in part A, what measures of center and spread would be appropriate. So looking back at that summary table, if it's skewed, it doesn't matter which way, but if it's skewed, it's better to talk about the median and the IQR. Those are more accurate measures for this set of data. Calculate the measures of center and spread that you reported. So the median we already did, 0.62 million. And the IQR would be Q3 minus Q1. So you might have to look back at one of our stats again, but that would be 4.8 minus 0.48, which gives us 4.32 million. Okay, the reason this is skewed is because these guys up at the top are making crazy amounts of money compared to the rest. Look at the next closest is 3.75 million, and this guy's not even making 1 million. Okay, so they're pulling the data, they're pulling that mean a lot higher. Okay, I want you to try the next one on your own. See if you can get the mean and median, and then answer all the questions here. All right, here are my final answers. So I used one var stats in my calculator to get the mean and the median. When I look at these, they're pretty dang close. So I would say that this set of data is symmetric. And I could also look at the modified box plot to check for outliers and to check the shape of the graph and confirm that it is about symmetric. So because it's symmetric, I'm going to report the mean and the range. Measure of center, measure of spread, mean 52.02, range I got 44.1.